Greetings. Welcome to another episode of Evil Dojo Raylib Game Development. I am Dark Mage. You can reach me on social media at Evil Dojo 666 on Twitch, Twitter, and YouTube here. I'm gonna run this. Let's see, this is running at regular speed. So, there's too much to say. Shoutouts to everyone who's followed and subscribed me. Please comment on my videos, though. I need some feedback, guys. I know y'all like what I'm doing, but I want some direction. I want some assistance and kind of guiding things going forward. But I am upgrading the videos. The one after this is going to be, I believe, full 1080p. So hopefully everyone appreciates the upgrade in video quality. Let's get started here. I've got two videos enrolled. This one's an hour and a half. I'm going to play it at 1x speed, or try to most of the way. Excuse me. I was playing around with a graphics demo recently, and I actually haven't done any annotation for that. But I had fun playing around with some 3D stuff and decided it's time to actually get down to business. Skull is, at the moment, being rewritten in raylib. The reasons for this are very obvious. Raylib is pretty damn sweet, I will say. It provides a lot of tools out of the box that are a little bit easier to access and work with than libsdl. That's not a problem, because I know enough about the process in general at this point that it should not take me very long to build a framework forward so that we can get back to where we were at pretty quickly and be able to start not only stubbing out new features rapidly, but also automate the testing process so that we can have headless instances of the game playing itself and attempting to find bugs that I haven't found yet. We're kind of far from that point, but it's an end goal. So at the moment in this particular video, oh fuck, I just noticed I'm redlining hard as fuck, so I need to be careful about my voice. Let me pause this and just test the audio to make sure that it's not too bad, because I want to give y'all the best quality possible. Okay, everything looks good to me, so we're gonna keep going. At the moment, I'm commenting out a bunch of code that I had already written so that we can get down to brass tacks. We can get down to a bare bones skeleton that we're going to start with. What do I mean by bare bones skeleton? So there's three fundamental aspects to a game loop. First, you have the handle input, then you have the world update, and then you have the draw function. Between these three functions, that composes essentially the game essence, or the essence of a game, from a software programming standpoint, right? Any game can kind of be modeled in this fashion, even non-video games. So we're getting down to just a raw skeleton where we're handling input but doing nothing. We're not updating anything, but we can update something if we wanted to. And we're drawing nothing, but we have the infrastructure to draw stuff. Take that back. We're not technically drawing nothing. We're actually drawing what I call the debug panel, which is just a block of text that sits in the corner of the screen and gives in-game variable information directly to you so that you don't have to have it print out on the command line or anything like that. So we're drawing to the screen, it works, we're just continuously whittling down code. One of the things that I do whenever I'm working on something new is I regularly comment things out while writing code. Like, I'll write several lines, and I'll copy one line, and I'll paste a line, and I'll comment one of them out, and then change the variables in another. I do this kind of thing all the time, so sometimes when writing files, my source gets littered with commented out, unused lines that no longer matter. So once I feel satisfied with the state of something, I like to go back and delete all those comments. Some people might say it's a waste of time, but it's purely for me a Zen aesthetic process, and a meditative one at that. The process of refactoring and cleaning up code can be quite therapeutic and stress relieving. Not to mention, when you're done, you get to look back at a work of art. It's effectively science, but still art, because cleanly written, well-formatted code can be visually appealing. I don't care what anyone says. And I know I'm not the only person to think this. Okay, so we got an error here. I'm attempting to pass a incorrect object through a parameter to a function call. The function call is update camera. So if you take a look around line 59, I've got a reference to a camera object called camera that is not a 2D camera. So what I discovered through doing this was that in raylib, there's a few camera objects, or like structs defined, right? There's a camera 2D, there's camera, and then there's camera 3D. And camera is just like an alias for camera 3D. But camera 2D has like none of the same properties as camera 3D. So you can't like write code for the camera 2D in the same way as the camera 3D, which is weird, right? So it took me a minute to realize this. So watch me struggle. I decided to comment that line out because it's not working for some reason. The reason I just explained, but there. I have it still working. It still builds and runs. But I hadn't yet realized that, oh wait, I need to make this a camera 2D reference. So camera controls work. Camera 2D has a target on it. So we got it working smooth because is key pressed is different from is key down. Just like in my libsdl videos, where I implement is key down manually using Boolean maps, raylib has it built in already for us. Ain't that sweet? What am I doing here? I don't know yet. Give me a minute. Let's see. Draw a rectangle. What am I doing? Just fucking around. I ain't doing shit. Oh yeah, I'm still trying to draw an image. That's right, we're trying to get the skull on the screen. First I try to load the skull sheet as an image object, which raylib has images as well as textures, and I believe the difference is more about like whether or not one has GPU access or not, because in the end you can't draw an image to the screen, but you can draw a texture. So if you want to like manipulate an image in memory before or after, you can do that. Let's see, so we're loading up the texture as a texture 2D, and we're setting up a rectangle which defines a source in the texture that we're going to be pulling from to draw it. This is really straightforward, basic sprite rendering stuff, right? So later on down the line, I eventually write classes to handle the sprite and the game world object. Those are still pretty early in the process, but eventually wrapping things in objects is going to prove useful when I sit down to actually do the unit testing framework. I believe we're going to be using CPP test or CXX test or something like that. I used it in a previous implementation of Skull. God, this is like going to be the third or fourth go at this thing. But I think this is going to be the last one. We're going to actually take it to completion this time. Reason being, raylib, it seems that good. Because I don't want to get stuck in the weeds putting certain things together. Like building it from scratch and owning the whole stack is super important to me, but I want to be able to easily port to the largest number of systems possible. While with libsdl I could very easily do Windows, Mac, and Linux, raylib claims to offer some iOS and Android potential support, which is intriguing. Skull might be a good candidate for a mobile phone game. It took me a while to figure out what I was doing wrong here. I decided to take a look at the examples. So this example loads a texture and does some basic animation in the same way that we're looking to do at the beginning of development here. Loads a texture from memory and then steps through a frame counter to keep track of like what frame you're currently on. Now remember that raylib is done entirely in C, so you don't get objects, and God bless Rayson, but Jesus Christ, this could be a little better. Of course, it's just a demo. right? Like, it works. Can't argue that. But back in my code, doing a little refactoring just to make it easier to modify things later. It's always a good idea to pull out hard-coded things into a variable. Standard computer science practice. Now, something about C++ and working with C libraries is that while C++ conveniently gives you access to a very nice string library, the string object itself is not interchangeable with character arrays in C. So you have to call the C_str method in order to get a constant character pointer for use in C functions. Common practice. As you can see, I declare const_char image path as a variable, and that way we can just use the straight thing. Still not getting the skull. Think about it. Think about it. Apologize for any food sounds. I'm eating an apple fritter. Actually, I should apologize again. I'm actually not sorry. It's fucking delicious. I got a whole nother one here too. Alright, so there's the demo. Looks good, working nicely. Notice the draw texture rec and draw rectangle lines functions. Decided to try and render a red box. See if we can't get something on the screen. I don't know why I swapped those around. I thought that was a silly idea. It's always width height. Or XY. Like. Actually, you know what I want to put on before I continue? I want to try and put on a voice meter. Hold on. How about now? Is this good? I don't know. We're going to try it anyway, so let's continue. Alright, so we're still fucking around and we're going to try and get this thing actually displaying. There's a lot of motherfucking background noise in my shit. I think to myself, is the order of the methods a problem here? I don't necessarily know yet. Actually, I kind of want to try my different visualizer here. Hold on. Okay, that kind of looks like way cooler. Better color too. Okay. Leave a comment saying why aren't we seeing our texture with our lines? Kind of perplexing. Previously we were crashing because we were attempting to load texture before we initialized the window. Just looking through the examples, seeing if there's any hints. One thing they're not doing is drawing to a target texture, which is one of the techniques I use to be able to stretch and shrink my game to fit any window that I want, which is really useful. Staring at this function, wondering what the fuck am I doing wrong? I'm not using camera mode anywhere. In fact, I'm like, what? We don't really need this, do we? I think what ends up fixing it is to do begin mode 2D and then begin texture mode. I think flipping those functions solves the problem. Taking a look at the cheat sheet, seeing if there's any sort of function calls that might be useful to us. Son of a bitch, really? Oh, no big deal. Okay. It was the order we were calling the modes in. Yeah. So we need to do begin mode 2D first, and then begin texture mode. That was it. Let's try it now. Ah, there's our skull. Top left, you can see him. So now I'm going to quickly implement the ability to turn the debug panel on and off. Using a Boolean switch, we can just simply implement an if checkmate. If checkmate, what the fuck is that? An if statement in order to check to see if draw debug panel is on, and then write a handler so that if we press the D key, we switch that variable from on to off. I pull it out into its own function, as is tradition. Here we can specify whatever string we want to write to the screen. Have a nice little box behind it. Here we have to pass a reference to the camera and the font, as those are not global variables. There's our debug panel key. And this was where I realized about the camera needing to be a camera 2D. So here I just make that 2D and that fixes that bug. I accidentally mapped D to one of the movement keys, so I changed these all to the arrow keys. Key up, key down, key left, and key right. I also realized that I need to separate the up, down, and the left, right from that whole if statement chain. Because if you don't do that, then you can only press one key at a time when you're moving, which is not very good. So I eventually fixed that. And now I'm trying to set it up so that we can actually draw the texture at a larger scale, because I designed the assets at a very small resolution on purpose, because when you scale them up, it retains a old school feel. So by designing in a minimal space, we can effectively mimic the design angle of making a game as if we lived in the 1980s. I mean, I did, in fact, live in the 1980s. Whoops. So while trying to render things out, I accidentally ended up copying that particular thing many times. That was not what I was trying to do. By playing with the rectangle, I is how I messed that up. But I have not yet separated out the source and the destination rectangles, because the draw texture rec function only takes a source a source rectangle. Its destination is a vector too, so I end up using a more advanced draw texture function. I tried draw texture X at first, but I eventually settled on draw texture Pro. I'm going to play around here with implementing these function calls that accept more parameters. Another reason that I want to be able to scale the textures on demand is that there might be levels or parts of levels where I may or may not want to zoom in, or I may or may not want to render the level at a particular scale. One of the reasons that we have the target texture to begin with is so that we can do this for all of the assets all at once. And actually, now that I say this out loud, I'm probably going to go back and remove the scaling from the individual sprites themselves and go back and set it up so that everything just renders at 1x, and then when we want to scale, we scale the whole target texture, and that's the only thing we scale. We have to be careful of that, I think, because like when we go to, like, say 4x, the target texture, right? Or even just 2x. Essentially, there's going to be a large part of the texture that does not display in the window. Which is fine, but it'll be like a majority of the target texture will be off screen. I'm not sure if this is a problem. It sounds inefficient as hell. But it might be better than trying to scale each individual asset in a scene. Now taking a look at the cheat sheet again, I take a look at Draw Texture Pro. As we can see, alright, let me go back. As we can see, Draw Texture Pro takes a texture 2D, a rectangle source, rectangle destination, a vector 2 origin, a float rotation, and a color tint. So we're going to use that now. Okay, so we ended up stretching it, but it is definitely much larger now. So we're hard coding in the destination rectangle, but by multiplying the width by scale and the height by scale, we got it to do that much. So by default, it's like appearing stretched, but the width that it's using is actually the width of the whole texture and not like the animation frame that we're working in. So now it actually drew both frames, but we want just one frame, and we want just that one frame stretched, or scaled rather. So So in order to do that, we're going to having to modify the width and the height of the destination rectangle so that we're dividing width. Well, we get back to it, but we're going to end up dividing width by 2, which is the number of clips in the sprite sheet. There's only 2 frames, and multiplying that by scale, and then just multiplying height by scale. Start with, I'm setting up so that we have a very easy to modify movement unit. So if I want to make the skull move faster or slower, we can do that. And there's our moving skull. Yay! Excellent. Woo! Okay. So now that we've got him moving, we still need to get him stretched. So, Copilot is still trying to do width times scale, but it ends up not working. We already tried it. That's what we got last time. And I'm thinking, oh, well, he's stretched, so we're on the right track. I just have to modify the rectangle a bit. Why is he stretched to begin with? That's the main question. He's stretched about the size of the whole sheet, right? So if you divide by 2, then we get the 1 frame, which is correct. But then, now we multiply by scale. I think. Come on, Dark Mage. You can do it. Come on, baby. Just get that multiplier in there, dude. Just right there. Let's fucking do it. There we go. Okay, now we have a big skull. And he's moving kind of slow. I'm like, okay, well, you could move faster. That's why I set up movement unit to begin with. So now I can just change this to whatever I want. I just said, okay, well, let's create a base movement unit of 1, and then base or actual move units would be base unit times scale, so they're appropriate, movement scales along with the size of however we're rendering them. So he moves pretty good now. $2X looks pretty good too. Okay, I turned off the fucking shit because it seemed like it was using too much CPU. I don't have a really great computer or anything. I wish I did, believe me. But we're gonna go ahead and keep trudging through this. We've still got like 45 minutes or so. So I'm gonna try and go through it at 2x. Because this is just cleanup right now. Nothing terribly hyper important to note, but you can at least kind of follow along with the transformation of code into better looking code. Because all this works, right? Now I want to refine it. Everything still works. Got a super big skull now. And we got a dog in the room. What's up, Gus? Oh no. You go down. Come on, let's go. Whoa. Uh-oh. Alright, let's keep going. Bit of a pause here. Bit of a... What am I doing here? What are we all doing? Okay, so I moved over rcamera.h and hack.ttf. Actually, rcamera.h was from when we were doing 3D stuff, which is why I just removed it. We add hack.ttf to our git ignore so I don't commit it. So now I'm pulling over the raylib C++ template that I've created into a new folder, skull raylib cpp. So we've got our skull still rendering at 8x scale. Just copying over stuff, make sure the font still works. So now I'm actually creating a game class. Let's slow down a little bit now that we're at something moderately interesting to talk about. Alright, like I said, time for something a little bit more interesting and basic. This is a standard way to set up a new object class in C++. Start off with pragma once, which is a replacement for the old define include guards that essentially prevent circular dependency during linking. I know that's a complicated topic on its own. Trust me, it's good. Pragma once ensures that the header file is only included once when linking and compiling, so you don't end up with situations where you have like multiple definitions cross, fucking each other shit up. So you have the class, or you have the word class followed by the name of the class, curly bracket, and then public and private, which are ways to define sections so that we can separate out what is publicly accessible versus what is privately accessible. Now, for those of you who don't know object-oriented programming or haven't traversed this path yet, public things are accessible programmatically to things outside of the class itself. Meanwhile, things that are privately accessible can only be referred to in the context of the class. And what I mean by this is, when we actually go to define our methods, which will be in the game.cpp file, those methods are going to be written from the context of the game class. So in other words, we'll be defining methods that instances of a game object will be able to call. Let's continue. There's our constructor. A constructor is a method, and a method is a function that belongs to a class. A constructor is a method that allows us to create or construct an instance or instantiation or occurrence of an object. So once we actually defined the constructor, we can, in another part of our program, create new game objects. So now we're in the .cpp. We're going to go and create our constructor. Start by including game.h. It tells us to import all of the different declarations that we've already written. A lot of the code that's currently in main is going to go into game.cpp. I realize one of the things we're going to need is unordered maps. An unordered map is like a dictionary in Python. C++'s standard template library has available to us both the ordered map, which is just called map, and unordered map. And they're both subtly different. It can be used in the same way. Alright, so we're copying some things over into our game class now. And actually now we're creating a sprite class. So we of course have to create our constructors, and I have to first start off by fleshing out what private properties this class is going to need. So the sprite's just a wrapper around a texture. We're going to use this to be able to implement movement as well as animation. So our first constructor, we're just passing a file path. And I realize, oh yeah, we're probably going to need a rectangle too. We definitely need an int frames. We're going to have to be able to specify how many frames are in a sprite sheet or strip. So we've got so far a texture, rectangle, position, and animation frames. Fuck. Hold on. Alright. We're back. So we're still implementing sprites. First, we're getting the basic constructor in. Okay, so entity ID is a alias to integer. What this allows us to do is kind of create our own type. It's just a reference, but we're going to be using these integers as keys into our maps. As an example, with sprites, it's an unordered map mapping entity IDs to sprite objects. Make it very easy for us. So in the constructor, we're going to do a test load. of our skull. Use my DaVinci tool on my back while I'm doing this part of the recording. Apologies if you can hear me breathing or cracking or anything like that. Maybe I should do some like dark mage ASMR where I breathe and crack into the microphone or some shit. So in a constructor for game, we're attempting to load up a texture for the skull sheet, attach it to a sprite object, and then insert that sprite into our map. Something to note about the constructor style on line 11. One of the probable biggest complaints in C++ comes from the myriad variant ways to do fucking everything. This is one of many different ways that we can call a constructor. One of the big differences between C++ and Java is that every instance of an object in Java this is not immediately apparent to introductory computer science students who have not yet taken C++ far enough to understand the difference between a pointer and a reference and a item on the stack, right? In Java, everything is a reference. So whenever you're referring to objects and you're passing them around between functions, you're actually passing references to these objects, not the whole object itself. The main reason for this is it would be a very expensive process if you had a big object and you wanted to copy that whole object as a parameter on the stack. So naturally, we would just pass a reference to it or a memory address. If we wanted to do this in C, we use pointers, right? But like in C++, we have a million different ways to do this, and we can actually declare objects, instances of classes, on the stack itself. So that's what we're doing here. We're actually creating a local instance of a sprite called skull. That's not a pointer. But you notice that it says no matching constructor for initialization of sprite. I'm like, what? I defined the sprite constructor. Why is it yelling at me? Well, let's take a look. First of all, I had to implement a texture 2D constructor where I've already loaded the texture and I can just use like a reference to it. We update the position to be XY. So we have texture rectangle position, animation frames. And we're about to have another constructor changing all the XYs to float. So you have two constructors now having different constructors in C++ is very useful, so that if you need to make objects in a number of different ways, you're able to. So now we're stripping out a lot of the main stuff because we're just about ready to actually shove in game, actually make all this stuff play nicely together. But first I have to set them up to compile and link. So we have the game object now representing the whole game, and a sprite object representing instances of sprites that we might want to draw on the screen. Some big error message going on here. Candidate expects 4 arguments, 0 provided. So immediately it's not apparent or clear what error is actually causing, because everything appeared to be building fine. And actually I think this is an instance where I had to like make clean, because like the game object was caching like an old version or something. And whenever you change things into .h, sometimes you'll need to clean your objects, because make is designed in a way where if the object exists and there wouldn't be a reason to rebuild it, right? Or unless there's been changes made. So but the .h though, because that's kind of separate from the object file that gets produced. Like, you could make changes to it and not touch other things, and all of a sudden your build's out of sync. So every so often it's important to clean your project. Verify that the whole thing builds correctly. Oh, there's a big crack. Ooh-wee. Okay. Let's fucking go. Oh yeah, so what I noticed was that commenting out the assignment somehow worked. But if I set it up as a pointer, everything all of a sudden plays nicely. I don't think unordered map allows you to copy a whole ass object into it. And I decided, oh, we should probably make it a shared pointer. Alright, so now we're ready to like actually make a game object. That's all we have to do is say game, game. And boom, we have a new game. So we're moving a lot of the game loop code into the game class as a method called run. So the main like game loop is inside that function now. So we have to declare it in the .h. We make a deconstructor for the game object. We set up their implementations. We set up the deconstructor. We just clear out the sprites and textures. We move over the debug panel on. We move over the font. Notice too that I'm commenting out every piece of main as I move it over into game. Okay, we're almost at the end of this video. Alright, so we're whittling things down here. Getting down to the meat and potatoes of this baby. One of the nice things about doing the audio for these videos is it gives me an opportunity to stretch in my bed. I'm working out some real deep kinks right now. Alright, render debug panel is now in the game class. You'll see that most of this code is pretty much the same as it was in the main. I realize too, I'm going to have to get a lot of this up on GitHub so that people can follow along in the videos, just like I did with the libsdl videos. Let's see what's going on here. So I couldn't find hack.ttf, meaning I don't have it in the right location. Okay, it built that time, and it ran that time. So we have the basics up. And we're at the very end of this video. I'm going to slow back down to 1x. Because next video is going to be full HD. I want to get this one out to y'all soon, so I'm going to clean up the audio tonight, put in the background music, and we should be good to go. It's like there's about a minute, a little bit over a minute left. But as you can see, the main, look at the main. Look how clean the main is right now. Oh my god. This is exactly what we want to go for. I wish all code could be this clean. You know, like, in essence, like, this is the entry point. This is where all the magic happens. Everything about this game is encapsulated between lines 11 and 14. Really just 11 and 14. I'm very excited to get these things built because the infrastructure is just so nice. You can have a lot of fun just building this thing in this kind of setup. So, last things last, I checked the code that I've already that I'm about to commit, and then we go ahead and commit it. Alright guys, so next video, look forward to that. Shout outs to everyone who's followed, liked, subscribed, shared the content. We're doing this thing, baby. C++, raylib, game development, Evil Dojo, 666, the mark of the coding beast, signing out.